Hi everyone. Thank you very much for tuning in today. Today's talk is about attacking Terraform environments. By the end of this talk, you'd learn ways to attack and secure your Terraform environments. This talk would cover a lot of things that probably not known before. One thing to say before we start, Terraform by default is not as secure as you would think. You have to put a lot of work to secure it. And what I'm aiming for is by the end of this talk is to learn about all the things that you can know so that you can secure your Terraform environments. And let's start. A little bit about me. My name is Mazin Ahmed. I'm an application security and offensive security engineer. I founded Full Hunt. It's a security startup that solves the attack surface visibility problem for companies and organizations. And also, I'm an occasional bug bounty hunter. I have been acknowledged by Facebook, Twitter, LinkedIn, Zoom, Oracle, and many other companies. And of course, I'm in love with cloud security. Anything related to cloud security, and of course, different things related to security are my passion. And that's why I put the effort into having this research made. The agenda for today is first we're gonna go over things, a background on Terraform. What's Terraform? How does it work? And why do we need to learn about all of this? Why is it important? Attack vectors and scenarios. And of course, the most important part is the demo, which will be really cool. The recommendations at the end, and then we would have a room for questions. So first of all, what's infrastructure as code? Back in the years when cloud was becoming a thing, if someone would like to deploy something, they would go to the console, take their time in deploying their resources from the console. And if they would like to do this again and again and maintain that, they would have to log in every single time to do that, which is a bit of a painful thing and does not really scale. That's why infrastructure as code became a popular thing in the DevOps and DevSecOps communities. Why? Because you would be able to write all of your resources in the cloud as code, and then you would be able to deploy it many times. And at the same time, you would allow room for peer review so that the people in your team and different teams would be able to review it. It's amazing. So, yep, it allows that part. And of course, one thing that you can say that once you have this being set up, you would be able to run it through CI, security scanning for compliance, and you can automate many things without really having to have someone to review everything being deployed. And of course, when you deploy this in using Git, you would be able to have an archive of everything being deployed. It's just an amazing technology that everyone loves, hopefully. And what's Terraform? Terraform is an open source infrastructure as code software made by HashiCorp around 10 years ago. And users define their code in a language called HCL or HashiCorp language. And then deployments and the entire infrastructure management happens through Terraform. Whenever you write code, you would pass it to a Terraform build binary, and then it will read the Terraform state of the current infrastructure, and then it will decide what changes should be done. Why I'm talking about Terraform today instead of all of Palomi or different or CloudFormation or different cloud orchestrator, because Terraform is the most popular IAC orchestrator on the planet. This year, a couple of months back, they have released Terraform 1.0. It has been a big thing for everyone that is working on with Terraform, and of course, it passes 100 million downloads, crazy numbers. Another thing that is cool about Terraform, once you have it, is you can write the same infrastructure code and have it integrated with different providers. So you can write code that allows you to deploy to AWS or Azure or GCP or anything else. And it's not only these no, 6 technologies and 6 providers that are there. They support more than 1,000 providers as of today. How you would be able to do this is, as a practitioner or a user, you would write your code. Then once it's ready, it will go through Terraform plan, and Terraform plan is like the way that Terraform would be planning your deployment and show you what would be changing. And then it would go through the apply. And once you click on run apply, it would be deploying directly to your cloud provider. The thing is, when you are running apply and plan on apply, this means that you are checking the drifts between the current code and what is there on the provider. And if you are applying changes, this means that you have write access on different things on your cloud provider. And who would have this? It would be Terraform. So setting up Terraform would grant it high permissions that allows it to do everything that you need to have it to do. While it sounds scary, it's the default thing. We have to just set it up in a way that could be secure and not rely on the default things and try to think better about it. As I said, with great power comes great responsibility. A single mistake here can lead to the entire compromise of the cloud provider or the cloud account. So imagine your entire AWS account being held for ransom. Someone would, like if someone compromised it, they would go into your cloud provider. They would be backing up all of your S3 buckets. They would delete everything. They would have it somewhere else, and then they would ask you for ransom. Imagine this. Ransom is not a thing that you would see only on your internal network or in your laptops. It's something that can be done also in the cloud. It's still not a thing today, but I can imagine that this will be happening in the upcoming years. And as I said about the Terraform states, the way that Terraform works is it would be storing all of the changes and all of the additions that it made in your cloud provider in a file that acts as a database called Terraform state. Every time you do a change, it would check it against that file and then would update it whenever there's anything. There are many ways to have your Terraform state being deployed. One thing is you can have it locally. Second way, that is, I think, the most common way by everyone that I know, is using a remote backend of S3. So that you would specify a bucket, you would specify a key, and then which region would you like to have this bucket on. And then Terraform would be automatically creating this bucket would be automatically pushing the changes in the state file there. And whenever it updates, it would synchronize with that key. So attack number one, or thing number one, if you have get object permission on the S3 bucket for storing the state file, then you would have access to secrets, access keys, and database credentials. So everything that is being deployed for the organization through Terraform would have a copy of it in the state file. So there's something like an RDS database would have their credentials stored somewhere, and that place would have a copy in the state file. Same thing if you create an IAM key, access key, then you would have it there, or any other secrets that you would define. or the provider would be defining for Terraform. So whenever you get access to an organization and a cloud account, try to search for if they have a S3 bucket that looks like it's storing secrets for Terraform. It would have the entire instructions for you to go further in the environment. Another thing is states on Terraform Enterprise. Terraform has an enterprise offering called Terraform Enterprise, and the normal Terraform that people use is a CLI binary that people would be using for deploying infrastructure. But with Terraform Enterprise, you would have SSO, team management, states management in different ways and configurations and different ways for your integrations. And Terraform Enterprise is amazing, but still the same problem of storing the states files exists on Terraform Enterprise. And how it works is you would deploy Terraform Enterprise as an instance. It follows a self-hosted model. Also, they provide a cloud-hosted model that they would be hosting it within an offering called Terraform Cloud. But let's focus on the self-hosted one that you can host in your infrastructure. The states can be stored in many ways. PostgreSQL, AWS RDS, S3, mounted disk, same instance disk, and many more. If you get access to any of these places would have access to the state file, and then you can copy this state file, inspect it for secrets, use these secrets for getting a step ahead. Right. Another thing to say, of course, we talked about Terraform Enterprise is deployed as an instance on the AWS account or in the cloud account. And if you compromise a TFE instance, this is the best place for attack persistence. And there are many reasons for that. One, once it gets deployed successfully, no one really touched it. Another thing is upgrades and maintenance rarely happen. Like, it's not a common thing that a DevOps engineer would go in and log an SSH to the server to see different things. Unless something is broken, then there is a natural upgrade that would happen. This is the only time that someone would go in and try to SSH to this instance. So this is one thing to add, and of course it's because Terraform Enterprise would have permissions to deploy to the cloud to your cloud environment. You would have the company would have to provide it with proper permissions to deploy online. So it would have probably admin access to your AWS accounts or any account that is being used for. If you get access to this VM or this instance, then you would have high permissions in doing whatever on the infrastructure. You can create new users, you can backdoor users, you can read buckets, which is something that is not really common, but of course you can do that. And you can do everything. And one thing that is funny here is, let's say that you are in engagement and the security team detected that the database was compromised because of the state files and all. They would ideally go and rotate the database keys. And how would they rotate the keys? They would rotate it through Terraform. That's a typical way, or one way actually. But if they updated it with Terraform, then you would still have the latest keys being synchronized on the Terraform instance, which is really cool. Let me pause for water. And as I said, Terraform Enterprise has high permissions, and it's not something that you should really put on the internet. But there are hundreds of organizations around the world that have their Terraform Enterprise exposed to the public. If there is a single 0 day here, I'm pretty sure this would be a nightmare for all of these companies. These are filters that you can use for just checking it out by yourself. Okay, we talked about how you can use this in your advantage with when compromising an AWS account that has or an AWS user that has access to the S3 bucket that stores the state files. But let's say that you were not really able to compromise the AWS account, and you get access to a developer machine, and this developer have access to Terraform Enterprise or Terraform Cloud. What things can you do here? Terraform have exposed a full dedicated API that can be used for automating functionalities and tasks. This can go from everywhere from updating users to provision plans to add comments and everything. And one thing that they have is an API called state version output. And this state version output API allows you to download the state file that you would have needed to compromise an actual IAM user or all of this. So now, if it wasn't really possible to do this, you can just go to the API and ask it for your state file nicely, and it would respond with the actual state file in plain text, which is nice. Of course, this will also contain sensitive data with clear text credentials and everything that could be fun. Okay, going further, a couple months back, Alex K released a blog post talking about Terraform Plan RCE. It's a problem that Terraform has it for over the years, but it wasn't really talked about within the Terraform communities. And this blog post has become a viral post about how this attack could be done in a practical way. And they were talking about how you can use a malicious provider or an external data source that could allow you to get code execution on the Terraform Enterprise or the instance that is running Terraform. And this can result in the compromise of the entire infrastructure when someone submits a PR that is not approved. What you're going to do is, if you find, let's say you landed on a developer machine, and this developer machine has GitHub token that allows it to push PR on the account that is being in the repository that hosts the Terraform code, and this one is integrated with Terraform Enterprise like the normal setup. What would happen here is, if you as a developer check out a feature branch and then push code with the malicious payload, or the attack that talks about the malicious provider that you're going to talk about, then you will get code execution on that server. You would get shell access. And this is really simple, and of course it's not really intended, and this should never happen in real life, but it has been a fight between usability and security here. it's hard to find a way to secure it. At the same time, it's hard to not allow something like external data sources to be used. Chris for Alex K for having this blog post written and shared to us. And this is an example of an actual proof of concept. If you'd like to test it out and you are authorized to test it, go in, copy the code that I have here on my screen. Of course, the slides will be public on my website and my blog, and just use this code and then push it in as a feature branch on and get the repository that is responsible for hosting the Terraform code, and then see the magic happens. You would get shell access on that machine. Of course, this is a big problem here, but the thing is, there other platforms are also vulnerable. It's not only a problem for Terraform Enterprise. Anything that relies on Terraform build would be vulnerable to this. Eric Osterman in 2018 tried to introduce a fix, and it was rejected. The fix was to use to restrict users from querying Terraform plan or within Atlantis to only a subset that is being specified. And this would grant security here and could be a temporary fix, but it does not really resolve the actual problem from Terraform. Ideally, you should not really be able to run code on Terraform Enterprises enterprise instance and get full access to there, or get access into the machine or the instance that is running Atlantis. This should, or even the developer machine that runs Terraform plan. This is not the thing, the right thing. All right, moving ahead. We talked about the attack that you can upload an external data source like this one to gain access there. But would it be fun if we can do this in a way that is not really detected from the PR? Let's talk about the evil provider attack. Publishing providers within HashiCorp's Terraform is automated. This is made to encourage publishers to push code to Terraform. But the thing is, trust but verify. We cannot really just push code and have it being trusted to be used by the community and by Terraform without really verifying its content or even having a way to detect attacks here. So let's say for example, that one of these providers or one of these 1,000 providers that are being used by people, it's not only these 6 or 8 providers, have been compromised and they have been backdoored. And we're going to talk about how. And if this happens and someone just say Terraform init and Terraform plan, what would happen is the attacker would be compromising the company. It would be chaos. But, I don't want to have this being as a theoretical attack that does not really happen in the real world and someone is discussing it in public. I would like to show an actual proof of concept about this attack from zero to the end. So let's start. First, let's try to set up a provider. I set up a new GitHub account. I called it Evil Terraform. Of course, I didn't want to use my my personal GitHub account because I know it may get suspended. We're gonna talk about this one in a bit. And then I developed a simple provider, and this provider was pushed into Evil Terraform / Terraform provider E. Of course, this is my picture. Anyone can know that this is the code that I have. And then I backdoored this provider with this code. This is a simple Terraform. This is a simple provider that would grant me a reverse TCP shell upon the execution to my server. And then I pushed it to the Terraform registry, and it was accepted. It was approved. I had my category as cloud automations because it automates my hacking here. And I will show in a bit what happened. Once I had the provider being approved by Terraform, I made a PR to push it to somewhere, and it looked like this. It's just the same way that we would be pushing providers in our companies. And now the fun part is the demo. Popping a shell in Terraform Cloud, hosted by Terraform. Hosted by HashiCorp. This is app.terraform.io. Right? And you would wonder from here is how is the detection here? Probably in a well-organized environment that is running a good EDR solution or antivirus solution, this attack would be prevented or detected, but it wasn't the case. I pushed the provider that I built into VirusTotal, and no provider really detected it. And back to the attack that we showed here, pushing the provider that grants me a reverse TCP shell got executed correctly within HashiCorp infrastructure, which is really bad. Imagine what could happen afterward. I haven't really exploited this further. I only stopped at this part, and I tried my best to make it as obvious to the security team to see how the team response would be like. And before I continue here, I wanna say that this attack is against the terms of use by HashiCorp. Running this in an account may result in account suspension. So how was the security team response? Within hours of my exploitation, they detected the evil provider attack and contacted me directly to chat about my findings. And then we discussed various ideas and thoughts to introduce a fix for the thing that was presented here. And HashiCorp informed me that they are really thinking about ways into having this being mitigated in for their customers. For the time being, there is no patch, there is no fix to introduce, and there is no way to prevent this. I appreciate HashiCorp's efforts in handling and analyzing the research. One thing to add is I was planning to make the responsible disclosure the next day of my tests, and before even going to the next day, they were the ones who were contacting me, and I really appreciate them being this proactive. One thing to add here is they are also thinking about starting their bug bounty program. At the current time, they don't have a bug bounty program, but this is one thing that they also are planning to have. Now, going to the recommendations. First, be careful. There's like you would have hard times in maintaining a secure Terraform environment. So being careful is my main recommendation here. Another thing is, I don't know, why is it like this? Okay. Another thing is when using SV as a remote backend, try to have a bucket access policy to prevent other users other than Terraform instance to have access to your instance. This way you can prevent like unauthorized access in certain ways. Of course, there are bypasses for this solution, where if you have another user that have access to modify the bucket access policy for this bucket, then they can delete the access bucket policy and then they can access the bucket here. But at least if you can use this as a protection, this would be a good way. Another thing is to continually update and review your Terraform instance. It can be easily forgotten in the noise, and if there is an attacker or an actor that lands on your Terraform instance, as like mentioned earlier, this is a great place for attack persistence. So it can be easily abused badly here, and then it can be easily for defenders to forget about it. So yeah. Another thing is be careful in permitting people to have write access, even feature branch access for your Terraform repository, because it can lead to direct code execution, and there is no way to patch it. I'm waiting for a patch to happen. HashiCorp and I were talking about different ways to detect the attack. Meanwhile, the actual patch is there, but it's just ways to detect it. There is no way to prevent it at the moment. Another thing is to maintain a Terraform instance in an isolated VPC that no one really access it on the internet. Do not really expose it to the internet. This is bad. The next 0 day that would happen, someone would scan the internet and probably compromise your organization because of this mistake, and it would be bad. And I think this would be lastly, state files are sensitive, like they contain a lot of from database passwords to SSL keys, SSL certificates, access keys. Treat them as sensitive data. And of course, a good idea is to set up CI check to detect rogue Terraform providers. This would aid in the exploitation discovery whenever someone is trying to exploit your Terraform setup. This is one thing to add as a defensive measure. One thing that HashiCorp security team asked me to add is the Terraform Cloud Security Model. This is a document that talks about different ways that that you can use for threat modeling your Terraform Cloud security, while at the same time it can apply for your Terraform enterprise setup. And now we are reaching to the end of the talk. Final thoughts. Terraform is amazing. I love Terraform. It brings several security features when implementing IAC with Terraform, but still, with great power comes great responsibility. Protect your Terraform environment. Stay safe and set up persistent monitor like Full Hunt to discover shadow IT, misconfigurations, and mistakenly exposed services. Of course, it would not really work out for all of the Terraform attacks we talked here, but yeah, just one thing to add here. And lastly, the questions.